Hello everyone, I'm Feigo from UBFC. Today we want to present our result of the fuel cell virtual testing using European project PANDA EMR approach. In this work, we developed using PANDA modeling approach of a fuel cell vehicle powertrain and vehicle body. This vehicle, as you can see on the picture, is actually from one of our previous European project called Mobypost. It's a light-duty vehicle used for the post office for the daily mail deliveries. In this vehicle, we have one fuel cell connected to one DC-DC converter, then connect to the DC bus through lithium-ion battery, and all the power will be supplied to two in-wheel motors through the inverters. As you can see on this table, this is really a light-weighted vehicle, only about 600 kilograms with a top speed of 60 km per hour, which is more than enough for the city use. The entire powertrain is a hybrid one. We don't have an electrical charger in this vehicle. We only have the hydrogen supply part, that the fuel cell, in addition to do the propulsion of the vehicle, they should also use to charge the batteries. For the model development, we have used the real driving cycle we measured from the post office in the last project. As you can see in this driving cycle profile, we have a lot of start and stop, which is normal, as you need to stop at each door to give the mails. However, in addition to the last project result, in this PANDA project, we reformulated entire models and developed new models for each component of our powertrain and vehicle bodies by respecting the N-level model organization, as well as the modular approach for each subsystems. That means we did develop the different level of complexity of models for different components, including dynamic model, static model, or quasi-static models. Regarding the representation, we adopted fully the EMR, energetic macroscopic representation approach, and we used this modeling philosophy for the simulation and to validate the result as well. As we mentioned before, this Mobypost fuel cell vehicle has a hybrid powertrain configuration. We have proton exchange membrane fuel cells supplied by the hydrogen to provide electrical power through a booster converter connected to the DC bus. On the same DC bus we also have a lithium-ion battery packs to ensure the peak powers and absorb the braking energy. And all this electrical power is supplied to two individual permanent-magnet synchronous machines through two inverters. The model we developed in this PANDA project are based on the equivalent sequence. You can see the fuel cell model with consideration of the thermodynamic voltage, different losses associated during the fuel cell operation, and all combined by a simple equivalent sequence. The same applied for the batteries. We have the modeling equations in the equivalent sequence form for the battery pack, as well as for the different power converters and motors. From what we have been mentioned regarding the different component and EMR approach, on this screen you see the final EMR model we developed in this PANDA project. You can see from the very left side we have the fuel cell system model connected to the DC-DC converters, then supplied to the DC link with the presence of the batteries, and then the entire model goes to the supply of the inverters, wheel, bodies, motors, and vehicles, aerodynamics, and so on, with feedback on the control of the different energy management strategy that the one we have already used in the previous project. So as you can see on this slide, the modeling approach is different than the conventional one we find in the MATLAB Simulink. that using the EMR will make it much easier to see the causality of the physics of different components, and also to help us to develop the different control strategies associated to it. In conclusion, in this work conducted in PANDA project, we successfully developed using the EMR approach of a fuel cell hybrid electric vehicle called Mobypost. This model has been validated using the real driving cycles and shows a very small error compared to the real measurement data compared to what we have modeled in the PANDA project. We also implemented the same model in different simulation environment and with different details of modeling approach, and both are validated through a Simulink environment or Siemens AME sim environment, and it can be used as an efficient tool for the system component design and testing, as well as the control development.